Hello students, this is your Prasanna ma'am from NEET World. Now we are going to discuss about one more important topic from the chapter Principles of Inheritance and Variation, that is sex determination. Okay, quite a times the questions are asked from this concept in NEET and EAP set. Okay, so from what areas you have to focus in this concept, I will be telling you. Okay, yes. Sex determination, first of all, know what is sex determination. Sex determination is nothing but development of sexual characters in the early stage of life in an organism is called as sex determination. What is it, beta? Development of sexual characters in early stage of life, is called as sex determination for any organism. So yes, this development of sexual characters at the early stage of any life of an organism is dependent either on the environment, or on the genetic mechanism or chromosomal mechanism, or it is based on the set of the chromosomes, whether it is haploid or diploid. If you look into the environmental factors, what organisms are dependent on environmental factors for sex determination? Those are turtles. What are they, beta? Those are turtles. Turtles are dependent purely on the environmental factors for sex determination. At the time of hatchling of eggs of turtles, at the time of hatchlings of egg of the turtle, if the temperature around it is less than 20 degrees Celsius, then they turn to be a male offspring. Then they turn to be what, ma? They turn to be a male offspring. Okay, if the temperature is more than 30 degrees Celsius, then the offspring turns to be a female offspring. Okay, so yes, here what is determining the sex of the individuals in the turtles? Purely it is temperature at the time of the egg hatchlings. Okay, this is environmentally dependent. Next, which is the major mode of sex determination we have to learn now more keenly, that is genetic or chromosomal mechanism of sex determination. This is advanced by the experiments of Henking, by the experiments of the scientist Henking. Remember this name, multiple times the questions are asked. So Henking conducted experiments, spermatogenesis experiments on insects majorly. On what did he conduct, ma? He conducted spermatogenesis experiments on insects and observed that 50% of sperms received one specific nuclear structure, that is X body. Okay, he received that in every successive generation. Only 50% of sperms received the structure X bodies, received a specific nuclear structure, and he named it X bodies. Then tell me, who are those scientists who said about X and Y chromosome? It is Wilson and Stevens who named that X and Y chromosomes are sex chromosomes. Who named that X and Y chromosomes are sex chromosomes. Clear, ma? So this is about genetic or chromosomal mechanism. Here what is more important, what you have to remember, Henking has conducted experiments on insects, that is he worked on the spermatogenesis of insects, and he said that only 50% of sperms are receiving a specific nuclear structure that he named as X body. Clear? And who gave us X chromosome and Y chromosome? Who named it X chromosome and Y chromosome? That is Wilson and Stephen named X and Y chromosomes, and they said it as sex chromosomes. And the third method of sex determination is haplodiploid mode of sex determination that you will observe in honeybees. Clear? Now, if you look into chromosomal basis of sex determination, if at all sperm is deciding the sex of an offspring. Sperm is deciding the sex of offspring, the gender of offspring, then it is male heterogamy. Either it has only one chromosome or it has two different types of chromosomes. Either the number of its chromosome is less than that of female set of chromosomes, or it has two different types of chromosomes. Based on that, the sex of the offsprings will be changed. And if at all the ovum or egg is responsible for the sex or the gender of the offspring, then it is said to be female heterogamity. It is of two types again, ZW and ZO. ZW where two different types of gametes are produced, heterogametic, and ZO where one chromosome is not produced, only one chromosome is produced. One chromosome is absent, that is why we are marking it as O. So, its chromosomes are less than that of males. Clear ma? So, this is female heterogamety, here it is male heterogamety. Females are homogametic in male heterogamety, here males are homogametic in female heterogamety. Clear? Next, we will look into each type more clearly. First, XXXO type of sex determination, that is male heterogamety. Most important thing is you have to remember the examples for each type. Example for XXXO are bugs, cockroach and grasshopper. Yes, so if you look into here, males have only one X chromosome, females have two X chromosomes which are homogametic. So, here one chromosome is less, on total you have 21, here on total you have 22 chromosomes for females. And when X is crossed with X chromosome, then you will get complete set, that is 22, which results in the formation of a female. Okay. When only one X chromosome is involved in the crossing, then there will be one chromosome will not be produced, then it is XO type. Then it is what ma? XO type, which is male. Clear? So, this is about XXXO type of sex determination under male heterogamety. If you look into the second type, that is sex determination in Drosophila, which is XX and XY type, which is what beta? XX and XY type. So, here in XX and XY type, females are homogametic, males are heterogametic. If X is crossed with X, again it results in the homogametic set of chromosomes, which results in the female offspring. If X is crossed with Y, then it includes heterogametic, okay, two different types of chromosomes, which gives you a male offspring. So, yes, if you look into XY, what is differentiating between X and Y chromosome? If you look into it properly, Y chromosome will have a region which is called as SRY region. Y chromosome has SRY region which includes testis determining factor. It includes what ma? Testis determining factor. This is responsible for the production of testosterone, and this will develop the sexual characters in male. Okay. So, yes, here Y chromosome has SRY region which has testis determining factor, which is responsible for the release of male sex hormones like testosterone. And most important statement based question is Y chromosome is shorter than X chromosome. Y chromosome is shorter than X chromosome, and on Y chromosome in this region testis determining factor will be there. This will be releasing the hormone testosterone, which develops the sexual characters in males. So yes, XY type of sex determination you will observe in humans and Drosophila. Clear ma? Yes. Next, if you see ZOZZ type of sex determination under female heterogamety. Here if you look into, females has only one set of chromosome, that is ZO. Females has only one set of chromosome, that is ZO, and males of course they are homogametic ZZ. So sperm includes two chromosomes, that is ZZ. Here if Z is fertilized with another Z, this will produce homogametic male offspring. If only one Z chromosome is involved for fertilization, then it is ZO, which gives rise to a female offspring. Don't get confused. Look here. If two Z chromosomes are involved in the crossing, this will give you a homogametic female offspring, okay, and if only one Z chromosome is involved, this will give you only ZO type, that is male offspring. And the examples you have to remember for this type of sex determination are butterfly and moths. Butterflies and moths, okay. This is what you have to remember for this type of sex determination. Next, ZWZZ type of sex determination. This is most important, and the examples of it are mostly birds. Examples includes mostly birds, fishes and reptiles, wherein males are homozygous or homogametic, that is ZZ, and females include ZW set of chromosomes. If Z is crossed with Z, again it gives homogametic male offspring. If Z is crossed with W, which is heterogametic, which gives heterogametic female offspring. Clear beta? So this is about ZW. Sperm crossing with Z type will give you male set of offsprings. Z crossing with W will give you female set of offspring. Clear? Fine? Understood? And the examples you have to remember are birds, fishes and reptiles. Now comes the concept of haplodiploid mode of sex determination. Haplodiploid mode of sex determination, which is very important focus. Here females, which include queens and workers, okay, always queen is involved for fertilization. So this has complete set of chromosomes. Complete set of chromosomes in honeybees include 32 beta. Complete set of chromosomes are 32. When complete or full set of chromosomes in honeybee is 32, what is half the set of it? Half the set of it is 16. Half set is 16 ma. Half set is what? 16. So yes, here when the complete set of chromosomes in the females, they undergo meiosis or reductional division, and they again give rise to two haploid sets of chromosome 16 and 16. This one set of chromosomes will be differentiated into male offsprings, okay, and these are also male offsprings, right? Sorry, excuse me. Yeah, and the other set will act as egg for fertilization. They will release sperms, males will be releasing sperms, and after fertilization this again forms a complete set of chromosome, that is females. Okay. Again they will undergo meiosis, forming 16 sets which act as, they are differentiated to males and they act as egg for fertilization, which involve in the fertilization. These males are drones or worker honeybees. Okay, drones. So if you look carefully, males doesn't have father but they have grandfather. Males has no father but they have grandfather. Okay, and they don't have son but they have grandson. Okay, here if you see honeybees, in honeybees the prominent feature or the statement based question will be asked, okay, that they don't have grandfathers have grandsons but no father and son. Okay, clear? So this is what you have to remember. Once again I will repeat, listen carefully. Females have complete set of chromosome, that is 32. They undergo meiosis and form 2 haploid sets. Okay, 16 chromosomes, those are male, okay, drones, male offsprings which act as drones. Other, one set of it acts as egg, fertilizes with sperms. Okay, they undergo mitosis and produce sperms. Okay, male offsprings only have haploid set, undergoes mitosis, sperms, egg and sperm will fertilize and they form complete set of chromosomes, that is 32, which is female again undergoing meiosis and producing haploid honeybees. Okay, haploid male honeybees. If you look carefully, male honeybees doesn't have father because they are formed as a result of meiosis from females. Okay, and they don't have sons too. Okay, they have grandfathers and grandsons. This is the concept to be delivered. And the example for haplodiploid mode of sex determination is honeybees. If you look into it clearly, you will understand it much better. Post fertilization female workers are formed. Of this, one is differentiated to queen and this is only undergoing fertilization with drone. Clear? So this is the concept wholly about sex determination. Finally, I would like to remind you about the examples of all chromosomal type of sex determination. You can take a screenshot of it if you want. So yes, chromosomal mechanism or genetic mechanism of sex determination include two types. One is female heterogamety, which included ZO type and ZW type. Okay, and male heterogamety, which is XXXO type and XXXY type. Clear? So yes, ZZZO type, we will discuss about the examples of all of them. ZZZO type examples include butterflies and moths. Okay, ZZZW include birds, fishes, reptiles. XXXO type includes bugs, cockroach, and most importantly grasshopper. XXXY type include humans and Drosophila. If you want, you can take a screenshot of it better. Many a times the question is asked. And haplodiploid mode of sex determination, you will observe it in honeybees. And then one more type you have to remember is sex determination based on the environmental factors. Example is turtle. And you have to remember who gave us X body, that is Henking. Who gave us X chromosome and Y chromosome? Wilson and Stevens, and they named it as sex chromosomes. Clear? This and all you have to remember. And Henking has conducted experiments on what ma? Insects, on the spermatogenesis, and he said only 50% of the sperms are receiving the X body. These are the major concepts which I have reminded you again from where the questions are asked. Okay. In the next class, we will come up with the most important topic, that is Mendelian disorders and chromosomal disorders, where I will be discussing about pedigree analysis as well. So, do not miss that session. Thank you.